Okay, now just like we had effective rates with our simple discount notes, we have effective rates with our compound interest. Yeah, go ahead. Good question. Could we use the table for this one? Because it is 60 periods, and the table only goes up to 30. You could if you split it down and did it like 2 years at a time, but the real problem there is the 5.9%. 5.9 divided by 12 is going to be like 0.4766 or something like that. It doesn't divide out well. So we really can't use the table. I said you could use whatever method you wanted to, but the table really doesn't work for that one. Good question. So let's take a look at effective rate. Now if we compound annually, the effective rate is just going to be the stated rate. What we have is the nominal rate, or the stated rate is what's given with the loan. The effective rate is what it would be if it were simple interest for a year. Now the effective rate is always just 1 year, except when the term is less than 1 year. And I'll show you what I mean as we go through some examples. So let's find the effective rate for $8,000 at 6% compounded quarterly for 9 years. First thing I'm going to point out right away, the 9 years is not totally useless. It does tell us that this is more than a year. So that means that we're going to use 1 year for the effective rate. So what we're going to do is we're going to find the interest for 1 year. So we're going to find the future value at 1 year first. So future value equals $8,000 times 1 plus 0.06 is our 6% as a decimal, divided by compounded quarterly. So it'd be divided by 4 to the power of 4, because we're doing effective rate, we're only going to go for 1 year. Even though this says it's for 9 years, we only go for 1 year to find the effective rate. So 8,000 times, parentheses, 1 plus 0.06 divided by 4, close parentheses, power of 4. We get 8490.91. $8,490.91. That is the future value. Well, what we need to know is the amount of compound interest. The amount of compound interest is the future value minus the present value. So here we had a future value of $84.90.91. Our present value was $8,000. So the amount of compound interest is $490.91. That number is now going to be used to find our effective rate. The effective rate is going back to the simple interest formula, I equals PRT. The amount of interest is the $490.91. The principal is the $8,000 that we invested. R is what we're looking for. We're looking for the effective rate. And our time, well, we went for 1 year. So normally we would combine the 8,000 and the time. Since our time is 1 year, it's just 8,000 times our rate. So we will divide by 8,000. So 490.91 divided by 8,000. 0.06136. To make that into a percent, we'd move it over 2 spots, 6.136%. And then, of course, you would round it off however MyMathLab asked you to round it. But you can see 6% was the stated rate, or the nominal rate. The effective rate sometimes called the yield, is 6.136%. Let's look at another example. Find the effective rate of $2,400 at 7.9% compounded monthly for 2 years. So again, we look at the time, the 2 years, and what do we need the 2 years for? What does it tell us? All we need to know is whether it's more or less than a year. It's more than a year, so we're going to go for 1 year to find the effective rate. So we're going to find the future value after 1 year. So that's 2,400 times 1 plus 0.079 divided by, this is compounded monthly, so how many times a year is that? 12. To the power of how many periods are there going to be in a year? 12. Again, the 2 years here we pretty much ignore once we know that it's at least a year. So 2,400 times 1 plus 0.079 divided by, oops, 79, get back there, divided by 12, close parentheses, power of 12. 2596.62. So that is the future value after 1 year. What's step 2? Find what? The amount of, there we go, compound interest. Which is just going to be the 2596.62 minus $2,400. So $196.62. So that'll be used to find our effective rate. 196.62 equals our principal of 2,400. We are looking for a rate, and our time is 1 year. So again, 2,400 times 1 is 2,400, so I'm just going to divide by 2,400. So R equals 196.62 divided by 2,400. 0.081925. Or 8.1925%. Again, round it. However, my math lab asked you to round it. Probably 8.19 or 8.2%. I'm going to have you guys try one. Find the effective rate for $7,000 at 5% compounded semi-annually for 4 years. I'll pause this. We'll talk about that in just a couple minutes. Okay, so first let's find, we know that it's 4 years, so it's more than a year, so we're going to find the future value at the end of 1 year. So 7,000 times 1 plus 0.05 divided by 2, because it's semi-annually, to the power of 2. So 7,000 times 1 plus 0.05 divided by 2, close parentheses, power of 2. 73.5438. So $7,354.38. So our compound interest is 73.54. Minus 7,000. So we get $354.38 in compound interest. So our effective rate, 354.38 equals 7,000 times the rate times 1 year. So divide by 7,000. Get that our rate is 0.05063. So 5.063% is our effective rate. Again, rounded to whatever you're asked to round to. How many of you had that? Cool. So now let me show you an example where the 1 year becomes more significant. Find the effective rate for $4,300 at 6.3% compounded monthly for 6 months. Of course, the significant difference here is the 6 months. It's less than a year. Since it's less than a year, we're only going to compound it for as long as it is. So we're going to find our future value at 6 months. So our future value is the $4,300 times 1 plus 0.063 divided by compounded monthly, so divided by 12. But it's not going to be the power of 12. How many periods are going to be in 6 months? 6. Compounded monthly for 6 months. There's 6 months, 6 periods. So that balance, that future value will be 4,300 times 1 plus 0.063 divided by 12 to the power of 6 gives us 4437.24. There's our future value. So we find our compound interest. 4437.24 minus 4,300 is $137.24. Now to find our effective rate, the 137.24 equals the 4,300 principal times our rate, but it's not just 1 anymore. It's 6 months, 6/12, or 1/2. So now we do have to combine the 4,300 and the 6/12. Get 2,150 times R. And we will divide by 2150. 137.24 divided by 2150. 0.06383 is our rate. So that is a percent. If we move that 2 spots, 6.383%. Any questions? Okay. Let's do another example. Find the effective rate of 8% compounded monthly for 9 months. Now you might be looking at this thinking something's missing. And what is it that you're thinking is missing? The principal. Yeah, how much? Well, it doesn't matter. It's the rate, the compounding, and the time frame that matters. We can pick a principal. We're going to use $1,000. So our future value, we're going to use the $1,000 times 1 plus 0.08 divided by compounded monthly, so divided by 12 to the power of monthly for 9 months is how many periods? 9. So 1,000 times 1 plus 0.08 divided by 12. Power of 9. We get 1,061.63. Now, of course, I'm going to subtract my principal of 1,000 to get $61.63 of compound interest. So that's the amount of the compound interest, $61.63. So $61.63 equals $1,000 principal times my rate times 9 months is 9/12. I'm going to combine 1,000 and 9/12, give me 750. Just multiplying 1,000 times 9 divided by 12. So now we'll divide by 750. So 61, 63. Let's do that again. Divided by 750 is 0.08217. Or 8.217%. What do you think? So you don't even need the amount of the principal to find the effective rate. So far we've looked at compounded monthly, quarterly, semi-annually. Compounded annually would be pretty simple. Of course, your effective rate would be your stated rate if it was compounded annually. There are other ways of compounding. We could do compounded daily. Now we could go ahead and figure out our number of periods, multiplying the years by 365 and do that. That is really kind of ugly. Not to mention we would have to correct for leap years and stuff like that in there if we did compounded daily. We are not going to use a formula for compounded daily. We're going to use a table on pages 466 through 467 in your textbook. Now this table works different from the previous table for the compound interest or the compound amount of $1 for future value. So let's take a look at how this table works. I'm going to start out, we're just going to work through an example to see how or a couple examples to see how the table works. Find the compound interest on $4,000 at, let's go 7%. Well, 7% isn't even on here. I gotta make sure I have a percent that's on the chart. It's 6%. Compounded daily for 2 years. So the two things we need to know, one is the annual rate. Notice it's not rate per period now. We're not dividing by the number of periods. It just says annual rates. That's just the 6%. But we do need to know the number of days. So that's going to be 2 years. And 365 is going to give us 730 days. Now, if you look on page 466 and 467, the top of this table says the compound interest on $100. So the first thing we have to do is take our $4,000 and divide by 100 to get 40. So that's the number we're going to use in the table. Next, we have to get the factor from the table. So we find the 6% on top. That's actually over on page 467. And we go down to 730. And we get 12.748573. So what do we do with that? Our compound interest is the 40 times the 12.748573. So 40 times 12.748573. 509.94. Yep, go ahead. That's on page 467 in your book. If you go to the 6% column, you follow that down to 730. You bet. Now notice what I wrote here. I wrote compound interest. I did not write future value. The $509.94 is only the interest. To find the future value, I still have to take the original $4,000 and add the interest. So my future value is $4,509.94. Right there. What do you think? Not so bad. Way different than using the other table, unfortunately, which I don't care for, but it works. Find the future value of $5,800 at let's do 5 3/4%. Compounded daily for 1 year. Why don't you try that on your own? See if you can make that work out. Okay, so we look up the factor in the table. We get 5.918047. That's 5.75 for our interest and 1 year, so 365 days. Did anybody look up 360 instead? Good. Where did the 58 come from? Well, it came from, we have to divide our principal by 100. 5,800 divided by 100 is 58. So we multiply those out, we get an interest of $343.25. So our compound amount, or our future value, I should say, is 5,800 plus 343.25, or $6,143.25. How many of you had that? Good deal. Now we can go through and find effective rate calculation off of that as well, and we're going to do that in just a second. But for right now, I also want to discuss something called continuous compound interest. Continuous compound interest is a very funny little thing. There are no tables for it, only formulas. Continuous compound interest is just kind of a fancy little buzzword that was used a lot in the early 2000s because the computers could do it. Some of your larger banks advertised it because it sounded like a really great deal. We are not going to calculate continuous compounded interest in here, but I am going to show you an example of it using this one up here. So the 5,800 at 5 3/4% compounded daily for 1 year. The future value for continuous compounded interest, and I'm praying that this works out because it's been a long time since I've done it and I don't have this in my notes. I'm going to take my 5,800 bucks times E. E is a natural constant, it's like 2.732, blah, 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 to the power of my rate, which is 0.0575, times my time of 1 year. Now again, this doesn't need to go in your notes, so you'll never be asked to repeat this, and I'm not totally sure if it's going to work right now. Where's my E button? There it is, second EDX, 0.0575. Cross my fingers. Hey, there it is, 61.4327. I haven't done that calculation since last year at this time, so I wasn't, and I don't have it in my notes, so I wasn't totally sure if that was the right formula. Notice the difference between daily compounding and continuous compounding, 2 cents. Yeah. But I mean, it was just a very flashy advertising campaign. Invest your money here. We're giving you 2%, but we're compounded continuously. Well, your neighbors down the street, they're compounded monthly. Your money is continuously working for you at our bank. Yeah, it doesn't make much difference. And a lot of banks have gone away from it because the computer software and stuff for updating it, there was glitches in the software and the problems with it. It just wasn't. The problems it created wasn't worth the hassle. So anyway, let's look at the effective rate. I want you to try this on your own. See if you can piece it together. Find the effective rate. For, we'll take it easy on $8,000 at 7.5% compounded daily. Years. So I'll give you a few minutes to see what you find out. So of course we're going to use 80. The 8,000 divided by 100 gives us 80. Then our factor for 7.5%, and are we going to use 730 days? We said for 2 years, but we're only going to use 365 days. Why? Because when we do effective rate, we go for 1 year. So we're going to use the factor 7.787585. How many people had that off right there? Was it 2 years? Okay, I figured that would catch a lot of you. So 80 times 7.787585. So your interest is $623.01. Now we don't need to add that on because we really don't care what the future value is. We're looking for the effective rate. So we have the interest, 623.01, equals our principal of 8,000 times our rate times 1 year, since we're past a year. So we're going to divide by 8,000. So 623.01 divided by 8,000. 0.077876. So the 5 decimal points that I'll move the decimal point over. 7.788%. Again, round however you're asked to. Any questions? Okay, I'm thinking that would be a great spot to take our second break. So it is about 7:14. Let's start again at 7:24.